Y'all are very good at following directions. Thank you. It happened a lot quicker than I thought it would. If anybody is in the back, just know we've got some space in the front. You're more than welcome to fill in. I'm also seeing some spots over here. Thank you all for coming. All righty. Another one right on the dot at 2 o'clock. We're going to stay punctual. Thank you all so much for joining us for this next afternoon session. Next, we're going to hear from Emily Iskin, postdoctoral research fellow at Boise State University, discussing Rewilding the Riparian West.
Thank you. It's so nice to see such a crowd on the last day in the afternoon. So I'm going to try to keep the energy up here for y'all and hopefully have time for questions and some input from y'all at the end of this. So today I'm going to be talking about spatial and temporal responses of river corridors to beaver restoration, really focusing on this temporal component and what we can do with remote sensing. And this is some work that I've done with, of course, not alone, but with colleagues at Boise State in the lab led by Jody Brandt. And we are funded by NASA on the same grant that Utah State University developed Flux with, that Sarah Koenigsberg has been working on. So this is really a collaborative effort. So beaver rewilding in Idaho. I'm not going to focus so much on the ecosystem benefits of having beaver in these semi-arid ecosystems, because we've heard a lot about that. But there's not many folks from Idaho here this week, and so I'm just going to share a little bit of what I've learned having been there just a year. So Idaho Fish and Game is famous in Idaho for having parachuted 76 nuisance beaver into the Frank Church River of No Return wilderness. So we've seen pictures of this, and there's videos, and people get really excited about it because it's different and interesting. Ethical concerns of the beaver aside, it was successful in terms of there are thriving beaver populations in the Frank Church River of No Return wilderness. And if you don't know much about this wilderness, it is in the center of the state. The Salmon River runs through it, and it's named after Frank Church because he pioneered the Wild and Scenic River Act. So this is something that's special to Idaho and that Idahoans are really proud of. But of course, this parachuting beaver idea really leads to all of these other things. We talked about the culturescape this morning. And like I said, this is something that Idahoans, again, are very proud of. You can go to the Boise airport right when you arrive in Idaho and buy yourself a mug with the parachuting beaver on it. So when I'm talking about beaver rewilding, I'm talking about relocating beaver and or improving habitat with restoration. And so Idaho Fish and Game has continued to relocate beaver in the state of Idaho, but no longer by parachute. So there's been an increase, of course, that we've heard a lot about this week on a number of projects implementing this process-based restoration with the goals of enhancing quality of potential beaver habitat and kickstarting these fluvial processes that are moderated by beaver dams. And this, of course, requires many partnerships. A lot of folks from these organizations are here this week, which is awesome. Again, this doesn't happen alone and in isolation. It takes a village. So really, we've heard some about this idea of success this week, and is this working? Are we having an impact on the landscape? And we know with any landscape change, in order to understand what's going on, we have to measure it. And so this includes how is this restoration and relocation affecting surface water availability? Idaho and states like Utah, Nevada have this very semi-arid ecosystem that has perennial streams but is pretty dry otherwise. What's happening with the vegetation in these areas where this is occurring and overall river health? Monitoring in the field can be really time-consuming and costly, and often benefits from a year or more of pre-data, which can be hard to get when we get this funding. The permits are there, it's ready to go. Hear about shovel-ready projects like go, go, go. Oh wait, we need data. Sometimes we don't have the ability to get that. And I'm not saying that remote sensing is a replacement for field data at all. I'm a field scientist. I believe that these work together. But there are cases where we don't have the resources to be able to do an in-depth field study before a site goes in. And looking for beaver dams from space can be challenging and costly, especially in small streams. We heard from Emily this week about mapping beaver dams in different ecosystems. We also heard about Kabam, which I'm also excited to start using, but that's mostly for the state of Colorado and the Colorado River watershed, which is pretty big, but it's not for everywhere, right? So we've got to find new ways to think about this problem. So what I'm going to be talking about today is how can we leverage existing free time series to measure change. So if you don't know, NASA has the Landsat satellite series, which has been in operation since 1984. So your parents or grandparents didn't have to be out there in these meadows remembering to take photos for you of what beaver were doing. You can access that data now, and it's free. So we've taken this approach, we've called it MRRMaid, which stands for the Mesic Resource Restoration Monitoring Aid. Pro tip, if you want people to remember something you've made, give it a cool acronym. So the way that we're going about this is we're focusing on a few different restoration projects across the semi-arid West. I'm going to be presenting preliminary data from Idaho today, but as I'll talk about again at the end, I'm going to be expanding this. So if you've got sites, I want to know about it. Again, this takes just a lot of conversations with current partners and new partners of what are your projects? Where are they? What was the restoration history? When you're thinking about time series, it's really important to know when things went in on the ground. And that can be hard information to find if you weren't involved in the restoration project. And we're using a hybrid data-driven approach to not just look at restoration sites, but to look at natural beaver meadows where beaver are active and have been for a while, and degraded sites within the same watershed to be able to compare the time series at those sites versus the restored ones. And so to do that, I'm using both BRAT and VBET, which are from the Riverscapes Consortium. I'll talk more about that in a second. And then we're using MRRMaid to map Mesic vegetation at these different sites. So MRRMaid has this QR code will take you to our homepage where you can access the apps yourself and use them right now. It's based in Google Earth Engine. It uses Landsat and Sentinel imagery. So there's a couple different products. There's two apps. One is Mesic Vegetation Persistence. That's MVP. I'll be talking about that today. But we've just got more funding from NASA to expand this and do more work. So keep tabs on this website. That's where we're going to post updates to what we're doing. But basically what MRRMaid MVP does is looks at the whole time series from 1984 to 2022, and it looks at when each pixel was Mesic or not. Is this pixel in the polygon that you draw, is it Mesic vegetation or not? And it calculates a percent of time that that pixel is Mesic vegetation. So what that gives us, in addition to a hydrograph, gives us phenology in these river bottoms of what's going on with the vegetation. And in these semi-arid ecosystems, we're using this as a proxy for surface water availability. These streams are often really small. These are 10-meter pixels, so we can't always get at mapping surface water directly. It's pretty hard with remote sensing in small streams, so we're using vegetation as an indicator of that. And then we're using some R Bayesian statistics to look at what's going on through time, and are we seeing change points in the data. So a little bit more detail about the methods here. So we're compiling these restoration histories, but also drought. So learning what the goals of the work was it to get beaver back in? Is it to widen the floodplain? The footprints, when, where, and then I'm using right now the Huck 8 drought monitor, and that only goes back to 2000. So you'll see how that impacts the data interpretation here in a second. But this is evolving, and so I'm open to ideas of other data sets for sure. This grouping of natural and degraded sites I mentioned with the restoration site, basically what I'm doing is I'm using the current BRAT and the historic BRAT with the knowledge that the main thing that changes in there is the vegetation layer. So I'm filtering the BRAT for each watershed to where the historic potential dam capacity is pretty high. So that's an area where there could have been beaver or were beaver. And then to pair that with a natural site, I'm then filtering the current BRAT to where it's still high, with the assumption that between historic and current, the vegetation hasn't degraded so much that there could still be beaver there. But then for degraded sites, I'm taking that historic BRAT, areas where dam capacity could be high and where current capacity is now low. So the idea is that the slope hasn't changed or the stream power hasn't necessarily changed in a big significant way, but that vegetation has degraded for some reason between historic and current. And then once I have those filtered areas, I go in and look for actual beaver dams and I go in and compare. So there's a bit of this data-driven approach to kind of filter potential sites, and then I go in and look and use expert opinion to pair these sites. I'm limiting it to the valley bottom for each reach, trying not to get too much uplands in there. And then I'm running the MRRMaid for each group of sites and comparing the time series. Right now, MRRMaid is available for the growing season, May to October, but it might be interesting to do this for the winter if we can get some cloud-free data. So something to think about. So I'm going to share some case studies. These are 2 from Idaho. The first is Baugh Creek, which you may have heard of. But if not, it's right smack in the middle of the state. That's the Rockies right there. Lots of wilderness right near the Frank Church River of No Return. So we know that Idaho Fish and Game has been relocating beaver here for decades. I've seen some information that says 20 years. I've seen other that says 30 years. So we don't actually know how many beaver have been relocated to this area, but they have been. And restoration of this river was in process or in the planning process on private land before the Sharps Fire burned this area in summer 2018. It burned 75% of the Baugh Creek watershed. So this is what that looks like. This is a picture from Joe Wheaton and Anna Branch. This picture and pictures like this have become famous for the Emerald Refuge, right? So we've got the burned to a crisp uplands, and we've got this green oasis that was not as badly burned. So this is Baugh Creek. The restoration goals of this project were to widen the channel, grade and store sediment, protect existing beaver dams that were there, and increase that lateral connectivity between the channel and the floodplain. Restoration occurred in fall 2018, right after the fire, and Anna Branch has continued monitoring and maintenance through 2021. Again, this is a partnership between a lot of folks involved. It takes more than one beaver believer to make this happen. So here's what this looks like from space. So in green here, this is part of the restored section. There was also some restoration on some of these other creeks, but I've isolated this part below the confluence of Haley and Baugh Creek. And I've paired that up here with a natural reach. So this is also Baugh Creek, but it's fairly far away. And there are beaver dams here, active ones, that I can see from space. And then there's this small degraded section over here off Sheep Creek. It's unnamed, given the information that I could find, and it is a degraded reach. You might say, wow, these look somewhat similar in terms of confinement, whereas this one's much smaller. I was a bit surprised, but also happy to see that when I filtered the BRAT on what used to be pervasive and is now pretty low, there weren't that many areas that lit up. So we're actually doing okay. It's not a hugely degraded watershed, which is exciting. So I took what I could and paired these sites. So a little bit of that history together. We're not quite sure, but we know there have been beaver relocated here for a while. And then there's periods of drought of varying severity from 2001, 2005, 2007, 2013, 2014. This is common across the West, not unique to Idaho. Sharps Fire burned the summer of 2018. Then 140 post-assisted log structures were added to this watershed. 2019, there was beaver activity noted. We don't actually know exactly when beaver showed up at the restoration site, but we know that they were there at least from 2019 onward. More structures were added, other ones were maintained, and then there was more drought. So let's put this on top of the data. So here's what the output of the data looks like from this R-Beast package. This top panel here shows the actual MVP data. So these open circles show Mesic vegetation persistence through time at the restored Baugh Creek site. So you get a value from 0 to 100 in percentage of time between 1984 and 2020 to when there was vegetation here. So what this package does is it pulls out the seasonality component and then calculates the probability, which for this is 0, but the probability that there was a change in the seasonality. So the hypothesis with this restoration is that there will be more water later in the season, that you'll get a shift in the seasonality. We're not seeing that necessarily here, but we also don't have a ton of post-restoration data, which is gonna come out as a theme. So it may not be affecting it yet. That doesn't mean it's not. And then this is the trend, the overall trend of the median of the data, and this is the probability that there was a change in the mean. Here's the drought laid on top of it, and the restoration. And what I'm just gonna pull out for you is that no changes in seasonality yet, or at least not that we can detect at the 10-meter scale. Low probability of changes in trend, but there are 2 change points. So this package also pulls out, identifies points where it thinks that the change has occurred. So it looks like maybe the Mesic vegetation is rebounding after this drought, and maybe reacting to the wildfire here. Hard to say if there's change due to restoration directly. It's hard to pull this out from a time series and isolate just one action in a watershed. But the average MVP of this site is about 30%. So I'm gonna swing through these really quickly for the next ones. For the natural site, no change in seasonality either, also low probabilities of trend, but maybe not as affected by periods of drought. If you look here, this line is more variable. This one's maybe more stable. And has higher MVP of about 50%. So the 50% versus 30% in the restored reach for the whole time series. For the degraded one, again, no changes in seasonality, low probability changes in trend, average MVP of about 25%. So that is lower than both the restored reach and the natural one. So this is encouraging. Show you one more example from Cottonwood Creek, Idaho. Cottonwood Creek is way down in southwestern Idaho near the Nevada border. As is common in Idaho and lots of areas in the semi-arid west, there's lots of livestock grazing, and that's the main land use challenge in this area. Restoration goals were similar to what the ones at Baugh Creek were, but also improving beaver habitat for translocation to promote water storage in this area. So this project was completed in 2021 with more work in 2023 and recently this season. If you ever hear of the Polderwood project, this is one arm of that. So there's 3 rivers down there, Pole Creek, Cottonwood Creek, and Alder Creek, and together they form the Polderwood complex. Again, this is a partnership between many folks. Here's what a BDA looks like at this site. Here's those paired. Natural is this one, Cottonwood Creek. Restored is this one, natural is this one, Black Red Creek, just one hill slope over, and then this area, Cat Creek, I've identified as degraded. So I'll show you these plots again. Drought, BDAs, 76 BDAs went in on Cottonwood Creek, more drought, more BDAs. Similar graph, I'm gonna just pull out the important points for you. Here's where the drought and restoration occur. Again, low probability in changes in seasonality. Some probability of changes in drought or changes in trend. So we've got some change points here. This is all before our drought monitor only goes to 2000. So could this have been a drought here? Is this a land use change that's going on? But then there's also change points here. It looks like maybe rebounding after drought again. It goes down right as the restoration occurred. Is that because of the restoration? Is it because of this drought that's occurring at the exact same time as the restoration went in? And do we just not have enough data to see if there's been change after that? Average MVP at this restored site is about 20%. Here is the natural site. So low changes, low probability of changes in seasonality, but we are seeing some bumps here. You can see the probability here, the max is 20%. So I'm saying this is about 10% chance of change. It's still pretty low. Low probability changes in trend, but there is a change point that's pulled out here. Again, not sure what's going on with drought because our data doesn't go back that far. Average MVP though is about 50%. So that's quite a bit higher than the restored reach. And if you look here, we've got quite a bit of variability here at the restored site, but in the natural site, much smoother. Maybe this indicates that these natural sites are more resilient and more stable. At the degraded site, we've got low probability of change in seasonality, maybe again some changes in trend, but it doesn't line up necessarily with the restoration, so we need to know more about these sites. Oh, sorry, but the average MVP is 8%. That's a lot lower than the restored and the natural reach. So really the key takeaways are that mean Mesic vegetation persistence is higher for these natural sites and the restored ones, but we need more data after restoration. And degraded sites have the lowest mean MVP. Drought and restoration history alone may not be enough to interpret these changes in seasonality. So if you have thoughts on what could be going on here, I would love to hear them. So I'm going to improve the statistical analysis and interpretation as I add more sites across the West, not just Idaho, and thinking about what other data sets we need to incorporate. I'm sorry, these are out of order, but including maybe a climate index that covers the entire Landsat catalog, not just through 2000. Maybe include MVP data from the entire year. We don't know what's going on in the winter, and that might be affecting the seasonality in the time series. So again, how can we tell if change points after a drought or restoration project are actually due to that drought or the restoration? That's something we need to look into, causality. Also, are the reaches too long? Are they too far apart, the ones I've paired? Are the floodplains too narrow? Or is the post-restoration time series too short to capture these change points? These are all questions I'm going to be looking into. And then I will be expanding the study to these other states as well. So what I'm looking for from all of you is sites with long restoration histories. If you have sites that were restored before 2018 or even 2010, tell me. I have funding to do this monitoring. So please let me know. Questions?
Great job, Emily. Thank you so much. So according to the schedule, we do have a 15-minute coffee and tea break, but if anybody wants to stay, maybe, do you want to give it like a couple of minutes just in case if anybody has any burning questions? Okay.
What I do differently, I'm just at the beginning of this process, so I'm going to be doing it over and over and over and over again. So lots of things are going to change, but I think the Bayesian statistics is really powerful, but I think I need to learn a lot better of how to interpret it. So I didn't develop these remote sensing tools. Other folks in my team did, so they probably do, but I don't specifically. Right. So these are actually Landsat pixels that are 30 meter, but they've been back projected using Sentinel to get them down to 10 meter pixels. Yeah. Rose. 100%. So the money and funding that we just got from NASA includes a plan to have this live on beyond Boise State. So Climate Engine is taking this on to update it year and year after we are gone, and it will be part of Climate Engine, so you can pull it into QGIS directly.
Thank you, Emily. Thank you so much. All right, with that, one more round of applause for Emily. Thank you, thank you. All right, and we will get started again at around 2:35. We'll meet you back here.